The journey of gravity, from falling off an apple to Einstein's space-time fabric, has been immense. Newton thought gravity as a force of attraction between two objects, but Einstein saw gravity as a phenomena which affects time.
As per Newton, everything thrown up comes down. It is certainly true in our day-to-day experiences. Newton gave a simple explanation to this. He said, two masses m1 and m2 at a distance r are attracted by a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Newton was able to explain the motion of planets around the sun, but the trajectory of Mercury completely deviated from the predictions. And then came a totally different perspective on gravity by Albert Einstein. In the universe of Einstein's great imagination, gravity was no more a force. It is a phenomena explained by something he called space-time fabric.
So what exactly is space-time? A space-time is a continuum having length, breadth and height, and the time is interwoven with these three dimensions, giving space a fourth dimension. The space-time gets distorted when a heavy mass comes in. Space-time can be visualized as a fabric of trampoline, and as I stand at the center of the trampoline, it gets warped. When I throw the balls on the trampoline, it moves along the curvature, and the motion of these balls along the curvature is what Einstein called gravity. Mass gives curvature to the space-time, and the curvature gives motion to the mass. According to Newton, gravity is a force of attraction between all objects having mass. But since photons have no mass, so it will not bend in space. But if Einstein was right, then gravity would affect everything that happens in the universe, even the light. So the distortion of space-time should also bend light. The presence of mass warps the space-time. Therefore, rays of light undergo bending when it moves along the fabric. And this answers the astronomical mystery of distant galaxies with same signature.
Einstein said, gravity can change time. But why this came to his mind?
To understand this, let us take an hypothetical scenario. Assume a cube of edge 3 into 10 to the power 8 meters. We define 1 second is the time taken by photon to travel from A to C. And Einstein postulated in his theory of relativity that the speed of light is invariant, that is 3 into 10 to the power 8 meter per second. Time is equal to distance upon speed, therefore 1 second will be equal to distance travel along AC divided by C. So the photon will take equal time in all three directions. If we place a massive mass in this box, it will result in stretching of the edges. So the length along A-B- is greater than length along AB, and similarly for other sides. Now we know time is equals to distance upon speed. Therefore, the duration of time along A-B- is greater than duration of time along AB in the previous case, and similarly for other sides. So T- is greater than T, and we can say clock ticks slower near the more massive mass. That makes us understand the relation between time ticking in interstellar with falling off an apple. The stronger the gravitational field, faster the time ticks, and the weaker it is, slower the time ticks.
Decades after giving his theory, Einstein was proven right when errors were observed in GPS system.
If I search for Breakthrough Prize ceremony, I'll be shown some different location. This error is due to fast ticking of clock on GPS satellite.
But Einstein told it with no GPS, no atomic clock, no present technology. I mean, what a genius he was, wow!
Earth rotates on its axis and revolves around the sun. What effect can it cause on space-time? Einstein predicted that such a motion drags and completely distorts the fabric. For instance, two massive stars reduced to 1/10 of their radius spiraling around each other churns up the space-time, sending out ripples along the fabric. These ripples are called gravitational waves. Can these gravitational waves compress and stretch space-time? This was answered after about 10 decades at LIGO using massive and precise laser beams running across L-shaped pipes of equal length. Mirrors at the end reflect the beam and produce the interference pattern on the observation screen. When gravitational waves come, the space stretches or compresses, which shifts mirrors' positions by different amounts. This results in shifting of interference pattern, confirming the existence of gravitational waves. Is time the only extra dimension in space, or there are many strings waiting to be untangled? Gravity is deeper than what we perceive.